converting vectors. So we talked about having unit vectors and how we can decompose something in magnitude and direction into its unit components. Let's come up with a vector here. We'll say that it has a magnitude of 3 units and a direction of -30 degrees. If we want to decompose that, all we really need to do is split it into x and y components, figure out what those are, and then write in terms of those x and y components as a unit vector. So in this case, vector b would look like its magnitude times cosine of its angle in the I hat direction, plus its magnitude times the sine of the angle in the j hat direction. Specifically in this case, that will be 3 units cosine of -30 degrees, I hat, and 3 times sine of -30 degrees in the j hat. Okay, so let's see. That'll give us 2.598. That 5 is bad. Give me a moment. I hat and minus 1.5 in the j hat. Okay, so that's pretty simple. You'd use the same kind of rule for taking polar coordinates and turning it into Cartesian coordinates to turn it into a unit vector notation in terms of I hat, j hat, k hat. So that's pretty easy, but what do you do if you've been given a vector in the other format? So what if it's been defined in a very Cartesian way, where we say our vector starts at this point and proceeds to that one? So it has a length of 1, 2, 3 hops along x and 2 hops along y. How would we find the magnitude and the direction of this? Well, it's the same thing as converting into and out of polar coordinates. In this case, it's converting into. So it would be the square root of x squared, we'll call this vector c, plus y squared, its components along x and y. You can also call them c sub x and c sub y. And if you want to find the direction, it's going to be an inverse tangent of the y component over the x. Alright, in this case, that's going to be the square root of 3 squared plus 2 squared, so that's the square root of 13. And I'll actually leave it as square root of 13 for now. And then we have inverse tangent of 2/3, which is around 33.6 degrees. So this particular vector c is square root of 13 along a direction of 33.6 degrees. And that's as simple as it is. You just have to remember this. Now, if I ask you for a vector and I don't specify I want magnitude and direction or components, you are free to leave it in whatever format you want. But always read the question. Sometimes the question will make it clear that I want the magnitude, or I want the magnitude and the direction. Or sometimes I may even request that you tell me the components, how much along each direction. So pay attention to that. It'll tell you how your final answer should look when you are done. But the rules for doing it are pretty simple, and you probably remember learning about polar versus Cartesian coordinates, and it follows very similar rules. Essentially, we're talking about vectors in polar format or vectors in Cartesian format. Alright, that's it for converting vectors. We've got adding vectors and scaling vectors and some other things coming up, so look forward to those videos.